folks, we are back again to solve our next question on parallel circuit. So we have a question under the parallel circuit, so I will take the reading. If three resistors of 10 ohms, 6 ohms and 5 ohms are connected in parallel across a 60 DC supply. To those of you who doesn't know, the abbreviation of DC is direct current. So direct current supply. So I'll take it again. If three resistors of 10 ohms, 6 ohms and 5 ohms are connected in parallel across a 60 DC, which means a direct current supply, calculate I. We have here the total resistance of resistors in the circuit, and then II, we have the current flowing through each resistor. So and then I, we have the total current in the circuit. I'll take it again. So calculate I, the total resistance of resistors in the circuit. II, the current flowing through each resistor. I, the total current in the circuit. So let's move to our board and then solve for question I, which says we should find the total resistance of resistors in the circuit or component. So let's go to our board now. Follow me. So on our board here, I've illustrated what I read on the screen, on our screen. So our resistor 1 is 10 ohms, our resistor 2 is 6 ohms, and our resistor 3 is 5 ohms. So we are asked to find the total resistance of resistors in the circuit. So now let's go about to find the total resistance of resistors in the circuit. So please, before I solve this question, I want you to know the difference between solving the total or resistors in parallel and solving resistors in series. So there is a slight difference in solving the total resistance of resistors in a parallel connection, and a difference between solving the total resistance of resistors in a series connection. So here we have this is a parallel connection, so we are going to, it's a change of formula. So the series formula is different from the parallel formula. So here I have my RT here. So we are asked to find our RT. So now RT, sorry, I have to put one at the top. So RT is equal to, so 1 over RT. So 1 over R1 plus 1 over R2 plus 1 over R3. Since we have 3 resistors, so we are going to write them according to the number of resistors. So here is the formula for a parallel connection. If you are calculating for the total resistance of resistors in a parallel connection, so here the formula is different from the series connection. In series, you just have to add the resistors to get your total resistance of resistors. So here we have 1 over RT is equal to, so 1 over R1 is 10, so 10 plus 1 over R2, so 1 over R2 is 6, so 6 plus 1 over R3 is 5 here, so it's 5 here, so 5. So then we have to find our LCM if we are going to solve for the total resistance of resistors in a parallel connection. Please note this: in a parallel connection, if you are going to solve for the total resistance of resistors, then we have to find the LCM before you can solve for the total resistance of resistors in a parallel connection. So we have to find our LCM. So now our LCM here, with my knowledge, I can say our LCM is 30. LCM means least common multiple. So our LCM is 30. 30. So 10 can go into 30 3 times. 3 10 30. 3 10 30. So 10 going to 33. 3 times 1 is 3. So 3 1 3. So 6 here will go into 35. 6 5 30. So 5 1 5. So now here 6 will also go into 36 times. So 6 1 6. So we have 6 here. So we are going to sum all of them up. So 1 over RT is equal to, RT is equal to, so 3 plus 5 is 8. So 8 plus 6 is 14. So 8 plus 6 is 14. So 14 divided by the 30. So we are not done yet. So if you see clearly here, 30 cannot go into 14, but 14 can go into 30. It could be a decimal number, but it can go into 30. So we reciprocate it up. So this RT, our total resistance, will go to the top, whilst our 1 comes down. So we want to find our RT, not 1 over RT. We want RT. So RT is equal to, RT over 1 is equal to 30 divided by 14. So it's clear now. It's making sense now. So we are dividing 30 over 14. So we have here our RT is equal to if my calculation set me right, it will be something like 2.14, right? So there we have our total resistance. So here we have our total resistance. So we are going to solve our next question on II. So we are going to move to our screen and then come to our board and then solve for the next question. Before I will do that, I would like to explain for those who don't understand the solutions. So I would like to kindly solve, or I'd like to explain it again to those who doesn't understand. So to those who doesn't understand, we are asked to solve for the total resistance of resistors. So in parallel connection, this is a parallel circuit. It's arranged in a parallel form. So it's a parallel circuit or component. So we have our R1 is 10. Note that R2 is 6 ohms, R3 is 5 ohms. So now, if we are going to solve for a parallel resistor or resistors in parallel, then we have to use a formula. So we have to use this formula, 1 over RT. We are looking for RT. So we have to use this formula, 1 over RT. So we have to find the LCM. So 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3 based on the number of resistors. So if I have 4 resistors, so I'll add 1 over R4. So based on the number of resistors, so to be added to. So coming down here, we have 1 over RT is equal to R1. 1 over R1 is 10. So our first resistor is 10. So plus 1 over R2. So our second resistor is 6 here. So 1 over R3. So our third resistor is 5 here. So 5 here. So we have to find our total resistor. So we have to find our LCM. So our LCM is least common multiple. So LCM of 10, 6, and 5 is 30. So 10 can go into 5 3 times. So 3, 1, 3. So we have here plus 6, 5, 30. So 5, 1, 5. So 5, 6, 30. So 6, 1, 6. So here we reciprocated it. So down here we have RT is equal to R1 because we are finding, or we are asked to find for RT. So we reciprocated it and we have 30 divided by 40. So therefore our total resistance of resistors is 2.14 or 2.14 ohms. That's our total resistors.